Hello students. Today we are discussing about periodic table. As you all know, periodic table is something that you should be knowing while studying chemistry. It is a very interesting thing in chemistry where you will be able to deal with the different kinds of elements and its properties, everything. So this is will be just a introduction for periodic table. So the modern periodic table that we are seeing these days, it is by a British physicist called Henry Moseley in the year 1913. And he said atomic number is more a fundamental property of an element than its atomic weight. So he said that is the atomic number should get more priority than atomic weight. Atomic weight is something that mentally fused before for the periodic table, and the modern periodic table considers atomic number instead of atomic weight. So that is called modern periodic law. The statement goes like this: the physical and chemical properties of the elements are periodic functions of their atomic numbers. The physical properties and the chemical properties of the elements, they should be a periodic functions of their atomic numbers. So when these elements are arranged in the order of increasing atomic numbers, the elements with the similar properties recur after every regular interval, and that property is called periodicity. When you are arranging the elements in the order of their increasing atomic number, the elements with similar properties used to recur after every regular intervals, and that periodic repetitions is called periodicity. And in a periodic table, you can see horizontal rows and vertical columns. The horizontal rows are called periods and the vertical columns are called groups. And if you are considering a periodic table, there are about 7 periods and 18 groups in a periodic table. And out of the 7 periods, the first period has got 2 elements, then it will increase. Only the first period will have 2 elements, rest of them have got more elements. So this is a general idea. In a periodic table, you have got periods and groups. Period constitute a series of elements whose atoms have the same number of electron shells. That is, principal quantum number n should be same for an element in a same period. So in a same period, if n is equal to 1, it should have 1s. And if the n is equal to 2, it should be 2s, 2p. These all comes in the same period. N is equal to 3 is 3s, 3p and 3d. This also should come in the same period. And there are different types of elements in a periodic table. And the right hand side, you can see a periodic table, an example for a periodic table. You have got noble gases. You have got representative elements, that is also called S and P block. You have got transition elements and you have also got inner transition elements. Noble gases, as you all know, this is the last one. The last group in the periodic table is the noble gas. And the representative elements is S and P block. S block is the first row. P block is the last row. It starts with the boron, this row. That is SP block. So S block and P block. And then you have got transition elements. This is the transition elements. Something that is between S and P, that is transition elements. And you have also got inner transition elements, that is F block. Okay, so you can find all these different types of groups in a periodic table. You have got noble gases, you have got representative elements, you have got transition elements, and you have also got inner transition elements. And as far as noble gases are concerned, their group number is 18. And helium, which you can find in the noble gas section, normally we are not saying helium as a noble gas. We don't consider it as a noble gas. We consider neon, argon, krypton, xenon and all as a noble gas element. And the common electronic configuration that you can find for every noble gas is ns2np6. That means it is completely filled. The s orbital, 2 electrons are there. p orbital, 6 electrons are there. For every noble gas, the ns2 np6, that is, it should be fully filled. So the n can vary, but the fully filled configuration should be there for every noble gas. Next is representative elements. Representative elements consist of, as I already told you, S block and P block. S block, you have NS1 as group 1 and NS2 as group 2. NS1 is group 1, NS2 is group 2. So all the elements in group 1 which is having NS1 configuration, it is belonging to S1, S block, and all the other ones it is having NS2, the last electron should go to the S orbital. That's why it is NS2, NS1 like that. So then it is S block elements. If your last electron is going to a P block or P orbital, then we can say it is as a P block element. Group consists of 13 to 17 are known as P block elements. 13 starts with the boron and then it goes till fluorine. 13, 14, 15, 16 and 17. And it has also got this electronic configuration ns2np1 to ns2np5. That is the general electronic configuration for a P block element. And also you can find a character like the metallic character is found to change from when you are going from the left hand side of a periodic table to the right hand side. The metallic character changes to non-metallic behavior. So that is one observation that you can always find in a periodic table. It starts with the metallic elements and then it goes on, and when you reach the other end, you will find non-metallic elements. Next is transition elements or D block elements. D block elements starts with this scandium. It will go till here. So the group 3 to 12 is considered as D block elements, and the outermost electronic configuration is like this: N-1 D 1 to 10, Ns 1 to 2. That is the outermost electronic configuration that should be present in any D block element. So they all are metals and are characterized by variable oxidation state, formation of colored ions and complexes. That is the peculiarity of D block elements. They are metals and they have got variable oxidation state. They have the property of showing different oxidation states, and they can also form colored ions. We can find a lot of colored ions in this category of elements. Next is inner transition elements or F block elements. They are these two rows are considered as F block elements. The atomic number should be 58 to 71, and that session is called the lanthanides or lanthanide series. And if the Z value is 90 to 103, it is said that it is actinides or actinide series. And the orbitals present are 4f and 5f. So these are the f orbitals that are present in the inner transition elements. They have also got incomplete N-1d orbitals also present there. And the outermost electronic configuration should be this: N-2, F1 to 14, N-1, D0 to 1, Ns2. That is the outermost general electronic configuration for an F block element. So all the elements of these two series, that is lanthanides and actinides, they all are metals. They also got variable oxidation state, just like we told in transition metals. They can also form colored compounds. And one of the other peculiarities that most of the elements of actinide series are radioactive. Most of the elements that we find in this session, the actinide series, are radioactive. So it has got a lot of applications and properties. So this is the general introduction for a periodic table. Thank you for your listening.